All right, Honors Chemistry. This is the answers video for Lesson 17, Gas Stoichiometry. The first two pages are just kind of some instruction. We didn't go over this in class, but there is a PowerPoint on this. But let's just go through this quickly. Gases have no fixed volume or shape, so they're unattached atoms, molecules, ions. We just call them particles that are floating around and can move freely and do not attach to other particles. They can be thought of as atoms or molecules that have enough energy to break away from other atoms or molecules. Generally, but not always, gases are suspended, that is, they float in the atmosphere. We will deal with gas laws in the coming weeks, but for now, all you need to know is the following important relationship. That at 0 degrees, that's the freezing point of water, and 1 atmosphere, the air pressure in San Diego at sea level, 1 mole of any gas occupies a volume of 22.4 liters at standard temperature pressure, and that is defined as what I just said, 1 atmosphere pressure and 0 degrees centigrade, which happens to be 273 on the Kelvin scale. The conversion factor is 1 mole, and it doesn't matter what the gas is, equals 22.4 liters. And that relationship is true at STP, 1 atmosphere, 0 degrees centigrade. We can alter the flow chart in this assignment as follows. So you're going to see, we're going to go ahead and draw that. But here, what you have here is exactly what we had before when we were doing stoichiometry with grams. And that is, inside the chemical equation, you must be in terms of moles, in terms of numbers of particles. Okay, what this is doing is it's counting 2 molecules of hydrogen for every 1 molecule of oxygen. It's going to give you 2 molecules of water. It's counting the number of particles. It doesn't care what they weigh or how many liters of space they occupy. We can also interpret this as moles. 2 moles of hydrogen gas plus 1 mole of O2 gas equals 2 moles of water molecules. Okay, the G stands for gases here, and that's how, so it's the same as it was when we were dealing with grams and moles. Now the conversion though here is from liters to get to moles. It's 1 mole at standard temperature pressure, 1 mole of H2 equals 22.4 liters. And you'll notice all these conversions are exactly the same because it doesn't matter what the substance is. It's just how much space does it take up. That's the volume, that's the number of liters. That will tell you how many moles that you have, okay? So down here, what we can do is we can actually measure things in liters, right? You all know what a 1 liter bottle of water or a 2 liter bottle of soda looks like, and so you can actually measure things in liters. So we'll do a couple of practice problems here. Let me go ahead and just run through this one. So it's a very simple conversion. How many moles of O2 gas in 44.8 liters? So you start with 44.8, and there's 1 mole of O2 for every 22.4 liters of O2, so you need liters of O2 to cancel out. You're trying to get to moles, and there you have 2 moles of O2 gas. Okay, and how many moles of H2O gas in 44.8 liters? So same question except a different gas, but the point is here that you still get 2 moles. It doesn't matter what the gas is. It doesn't matter what the substance is. 1 mole will equal 22.4 liters at standard temperature pressure, 0 degrees centigrade, and 1 atmosphere of pressure. Okay. These examples show that the relationship liters to moles of a gas does not depend on what kind of gas. We can combine the flow charts we have for grams of solids, and it could be grams of solids, liquids, or gases, as long as they're pure substances. You don't have them mixed together, with the diagram for gases and convert them between grams and liters. So if we look at the flow chart we have here, now on this one I put the liters up on the top. It doesn't matter. So if you're given some number of liters of any of these substances here, you use that conversion that we just mentioned to get into moles. Now once you're in moles, you can either come back up to liters up here of some other substance, or you can go down. In this case, you use the molar mass conversions that we've been using for the last month or so. in this class, okay, and get to grams. So you can start with liters and come out with grams, or you can start with grams and come out with liters, or any combination, liters to liters. And of course, we in many problems before have done grams to grams. Okay, so point is, when you go up, if you're down here, you have to go up into the chemical equation. You can only move sideways inside the chemical equation between the substances. Once you get to the substance you're interested in, then you can move out, going up to get the number of liters of gas, or come down to get the number of grams of that substance, whatever it is you're trying to do. All right, so let's go ahead and let's do a problem here. One of the sample problems. So how many grams of H2O can be formed from 11.2 liters of H2 gas? Okay, so I'll try to keep the whole thing on screen here. I don't know if I can. Best I can. Okay, so how many grams of H2O? So we're looking, here's the grams row, and here's H2O. So the question mark is right here. It's asking how many grams of H2O. And it says formed from 11.2 liters of H2. So here's the liters row, and H2 is over here. So it's 11.2. All right, so you're starting here, you're ending here. So see if you can determine your path. You've got to come down into the equation, straight down. So this is going to be your first conversion. Then you come across from here to here. So you're converting from 2H2 to 2H2O. So you would simply, your conversion would be 2H2 equals 2H2O. Don't forget to put the word moles in. 2 moles H2 equals 2 moles of H2O. So now you're over here, you've made that conversion, and then you want to come out to your final answer in grams of H2O. So you use the molar mass conversion here that we've used many times before. So it's 3 conversions, 1, 2, 3 to get to there. So the first one is what we put way over on the left. Think about that. What we put on the left is what we know, 11.2. It's 11.2 liters of H2. Then our first conversion is this one. So you're going to put one of these over the other. Which one is it? Well, down here you have liters of H2. That has to cancel out because it doesn't appear in our final answer. So you're going to have 1 mole of H2 over 22.4 liters of H2. So the liters of H2 cancels out. Now you have to come across from here to here. So that's going to be, think about which one of those goes on the top. You have moles of H2 right here. That's got to cancel out, so we come over. So it's 2 moles of H2O over 2 moles of H2. So moles of H2 cancels out. Okay, so now you're right here in this box. Now you need to come out to here using the molar mass. Which one of these goes on the bottom? Well, you have moles of H2O here. That's got to cancel out. So it's going to be 18.02 grams of H2O over 1 mole of H2O. So the moles of H2O cancels out. And now you can multiply 11.2 times 1 times 2 times 18.02, and then divide by 22.4 divided by 2 divided by 1. And that gives you an answer of 9.01 grams. So you started up here, you came down, you came across, you came down. Okay? All right. So let's go ahead and do the second example, and then we'll move on to our homework problem set. Okay, so the next problem is how many liters of H2O can be formed from 2.4 grams of O2? How many liters of H2O? So liters of H2O. Here's H2O, and liters is slightly off screen here, but it's up there. That's where a question mark will go. It's asking for liters of H2O. And it wants to know from grams of O2. So here's O2, here's the grams row down here. So it's from 2.4 grams of O2. Again, O2 column, grams row. That's what they're asking for. They're giving grams of O2. Okay, so how do you get, what's your path? You first have to come up into the equation using the molar mass conversion to get number of moles of O2. Then you come across using the relationship of 1 O2 equals 2 H2O. Those are moles. Everything inside this dashed line are moles. and that gets you over to here. And then finally you come out using the standard conversion at standard temperature pressure, where 1 mole equals 22.4 liters, and that'll tell you how many liters of H2O you have. Okay, so let's come down here and do that. So the first thing that's going to go over on the left, you may not be able to keep the graphic organizer on screen here. The first thing on the left is going to be 2.4 grams, this right here. Then your first conversion is going to be the molar mass. You need grams to cancel out and moles to appear. You need grams of O2 to cancel out here. So that means that it's going to be 1 mole O2 on the top and 32 grams on the bottom. Grams of O2 cancels with grams of O2. Now you need to come across from 1 mole of O2 to 2 moles of H2O. I'll show that to you again. 1 mole of O2 to 2 moles of H2O. So which one of those is going to go on the top? Well, you need moles of O2 to cancel out. Whatever's on the top of the previous conversion is what has to go on the bottom. So it's 2 moles of H2O over 1 mole of O2. So that moles of O2 cancels. And then finally, you need to, you're sitting in this box right here at this point, you need to come out to get the liters of H2O. So you're using the standard liters to moles conversion there. Which one goes on top? Come back down. Well, you have moles of H2O that's got to cancel out, so that's going to go on the bottom, and the 22.4 liters H2O is going to go on the top. So cancel, cancel, and there you go. So your unit's set up to where your final unit is liters of H2O. Multiply everything on the top, divide by everything on the bottom, and you get 3.36 liters of H2O. All right. Okay, this actually should have been on the next page, so let's move on. So now we're going to do the assignment problems here. And what that instruction said to do was draw the graphic organizer here. So I'm going to take a moment and go ahead and do that. You take a moment and go ahead and do that too. All right, and we are back. So I have drawn the graphic organizer for this problem. So let's look at what we have. The one thing I didn't draw was the dashed line around it, and I'll go ahead and do that. So this is inside of the chemical equation, this dashed line, and that's the chemical world, and everything in there is expressed in moles. It's numbers of particles of each of these substances. So I'm going ahead and do that, and come on over here. Okay. So this is inside the chemical equation in moles. So down here we have mass in grams. To get from mass in grams up to moles, number of particles, we have to use the molar mass. So that's what we did in lesson 12 and since lesson 12. So you've seen this before 1,000 times. Now this up here is what's new. We're going to write down, that's whichever one of these substances we're interested in. It's the volume in liters. And then there's the standard at STP. And it says STP reaction. By the way, the next reaction on the next problem is also at STP, although it doesn't say it. We'll write that in. Okay, so at STP, then 1 mole equals 22.4 liters. And we're going to derive that toward the end of this lesson. Okay? All right, so you're going to go ahead and the first question is, so again, you write this in pencil, what I'm about to do, because you're going to want to erase it after each problem. How many grams of C3H6O are required to create 6.4 liters of O2 gas at STP? Okay, so 6.4 liters. So liters is up here, and it's CO2. So that's this column. So 6.4 liters goes right there. That's where the 6.4. It's liters of CO2. And it's how many grams of C3H6O. So here's C3H6O, here's grams, there's the question mark. So your goal is to get from the number to the question mark, okay? So how do you do that? You come straight down. You have to go through this conversion, so that's going to be your first conversion. So you're going to put one of those on top of the other, and you want to add the word CO2 and CO2 because that's specifically talking about CO2. So that's going to get you down to here. Then you need to come across to moles. This is a moles to moles relationship. And I always like to write coefficients even when it's 1, even though you don't traditionally do that in chemistry. I want to emphasize there's a number there. So you're sitting right here. You need to get over to here. So that relationship is 1 mole of C3H6O equals 3 moles of CO2. It's just exactly what the chemical equation, that gives you the conversion there, okay? And then once you're sitting in this box here, you need to come out to here using the molar mass. Okay, and again, one of these is going to be over the other, all right? So go ahead and let's set that up here. So we're going to start with 6.4 liters. And again, even though you don't write it here, you write it, it is CO2. It's always unit of measure and what the substance is. Okay, way over here on the right, we're looking for grams of C3H6O. Little line like that, okay? And we saw that we're going to have 1, 2, 3 conversions. So if you still like to draw the boxes, go ahead. Okay, so now your problem is set up. Okay, just write the conversion down below each one. So the first conversion we need is going from here to here. That's this one right here. So it's 1 mole. Go ahead and add the substance now, CO2 equals 22.4 liters. Okay, so which one of these, you want to ask which one goes on the bottom. Which one is going to make this cancel out? This does not appear in our final answer, this liters of CO2. Final answer is going to be grams of C3H6O. So this one has to go on the bottom here. All right, so it's going to be 22.4. And the other one is going to go on the top. Okay, so liters of CO2 cancels with liters of CO2. So now you're sitting in this box right here. Now we need to get over here. So our second conversion is between these two. So I'm going to write 1 mole . Okay, so 1 mole of C3H6O equals 3 moles of CO2. There it is, okay? Which one has to go on the bottom? It's the one that's identical to this, moles of CO2. So it's this one right here. Okay, and the other one goes on top. Okay, so moles of CO2 cancels with moles of CO2. So now you're in this box right here and you need to come out. So this is going to be your conversion, the molar mass there. Okay, so there you go. Which one goes on the bottom here of these two? It's got to be this one because it's got to cancel out. The other one goes on the top. Okay, so moles of C3H6O cancels with moles of C3H6. The only unit left is grams, which is in the final answer, so everything sets up properly. All right, so now you're going to multiply. Just punch in one. You can punch this in as one long equation. 6.4 times 1 times 1 times 58.09. Now hit the divided by sign. Divided by 22.4 divided by 3 divided by 1, and that equals 5.53. Two significant figures because of the 6.4 there, so 5.5. Okay, and that's your final answer. All right, so again, work this a second time, a third time until you can do it perfectly. Okay? All right, let's go. Let's keep going. All right, so B is asking how many liters of O2. So we can go ahead and just fill these in. You're hopefully getting experienced enough that you can do that. So it's liters of O2. So it's O2 and it's up in the liters row. It's asking how many. That's the question mark. Gas at STP, so that means we can use these conversions. If it's not standard temperature pressure, you cannot use those conversions. you'd have to do what I did in the instruction video, which is calculate the number of moles using PV equals nRT. I'm not going to make you do any of those on this assignment, but you should understand that concept. So this is only at STP. Are required to produce 17.84 liters of H2O. So here's the H2O column, and liters is up here, so it's 17.84. Okay. All right. So we know it's liters of H2O because it's in the H2O column and it's in the liters row. So that means it's liters of H2O is that number right there. So we need to start here, come down into the equation, into the chemical equation. Then we can move laterally, move sideways. And there's the two conversions. To come down, there's your conversion right there. To move sideways, it's 4O2 equals 3H2O. One of them goes on top, one of them goes on bottom. And then once you're sitting here, to come back out to the question mark, you need to use this same conversion, moles to liters conversion. So it's the same for every substance. All right? So go ahead and see if you can set this up entirely on your own. And, okay, so first we're going to start with 17.84 liters of H2O, and that's going to be our, we have three conversions first of all, so let's go ahead and write that 17, a little higher. And we have 1, 2, 3 conversions, so we can go ahead and draw the 3 boxes here. Okay, and I did a little out of order. My question mark should go over, and that's volume, that's liters of O2, so that comes way over here. Okay, so now we're set up to go ahead and start picking up our conversions. So the first conversion is 17.84 goes through this. So you write that down. And it's of H2O. Okay, which one on top, which one on bottom? The one on bottom has to be the same as this one. That's all you have to remember. So that would be the 22.4 liters. So cancel and cancel. So the other one goes on top. Okay, second conversion. We're now sitting in this box right here. We need to get over here. So it's this, 4, just add the word moles. And versus 3 moles of H2O. Just set an equal sign between them. Okay, so we have these two. Which one goes on the bottom? It has to be the same as this one because this has to cancel out. So it's the 3 moles of H2O. Those two cancel. And now the last conversion is going to be just this again, the standard liters to moles conversion that applies to all of these. It's the same one. Okay, which one goes on the bottom? It's got to be the same one that's here, moles of O2. So it's 1 mole of O2. Okay, and moles of O2 cancels with moles of O2. Last man standing is liters of O2, so that's it. Okay. So now, if you look, you can do a little canceling here. You have a 22.4 liter on the top, and a 22.4 liter on the bottom. You can cancel the numbers without canceling the units. All the way through this, we've been canceling units without canceling numbers. Now we can cancel the number 22.4, 22.4. Okay, if you don't want to do that, just multiply everything on the top, divide by everything on the bottom. Okay, so it's going to be 17.84 times 1 times 4. We canceled that out. Divided by, we canceled that out. Divided by 3, divided by 1. And if you do that, what you end up with is you end up with 23.78. And we have 4 significant figures here. We only had 3 there, though, and 3 there. Even though you canceled them, they still are part of the significant figures. They still limit your significant figures. And these single digit for moles do not limit significant figures. Just remember that, okay? So that means you're going to have 23.8. liters, okay? And that's the 3 significant figures there. All right? Again, study that. Watch it again. Turn the video off. Try to do it by yourself. That's where you want to get, where you can do these by yourself without looking at the video or looking at the answers. Okay, next up. So the first thing I'm going to do is go back and erase this and this, because we're done with that. Again, write that in pencil. You can write the graphic organizer in ink, but write that in pencil. All right. How many liters of O2, of H2O gas? So we'll come up here, and it's asking for how many of H2O gas. So this is the liters row. This is H2O. So it's asking how many there. Can be produced from 2, that should be, that looks like a comma, that should be a decimal point, 2.25 grams of O2. So we're going to come down here, here's O2, the grams row is down here, so it's 2.2. Okay, so we need 3 conversions again. We need to get from here to here using the molar mass, and that really should be 32.00, and that matters for the purpose of significant figures. So you use this molar mass to get to here. Then you use the same relation we just had. 4 O2, 4 moles of O2 equals 3 moles of H2O. That gets you across to here. And then you use the moles to liters conversion to get out, to get from here up to here to your final answer. Okay, so it's 3 conversions. It's going to start with 2.2 grams of O2 and end with some number of liters of H2O. So see if you can write this out on your own. Okay, there you go. It's set up. First conversion is right here. Okay, which one goes on the bottom? It's got to be the same as this one right here, grams of O2. Grams of O2 cancels and cancels there. Okay, now your second conversion is 4 moles of O2 equals 3 moles of H2O. Okay, which one of these goes on the bottom here? It has to be the same one as this. Moles of O2 cancels moles of O2. Then your final conversion. You're now in this box right here. Final conversion, you use this conversion to get out to there. Okay, which one goes on the bottom? It has to be the same one as this one right here. Okay, so moles of H2O cancels with moles of H2O. You end up with liters of H2O for your final answer. So we're going to multiply everything on the top and divide by everything on the bottom. 2.2 times 1 times 3 times 22.4 divided by 32.00 divided by 4 divided by 1, and that gives us 1.16. We're limited to two significant figures, so we're going to round that to 1.2 liters. Okay, and that's your final answer. All right, what I'm going to do is give you the answers only, not the solution. So you work the problem, you set it up. This, let me emphasize again, please, guys. I'm not trying to be this is just the way chemistry problems are done, is this. This is not my method. This up here is. This is not. You need to lay the problems out like this. I don't care about the answer. I care that I see that you laid the units out properly. When I check your work, I'm checking these conversions to see that you set them up properly. Okay, if you did, you'll get the right answer. All right, so I'm going to go ahead and give you the answers to the D and E on this. All right, so here are the two answers for D and E. So your task is to go ahead and set them up and be sure you get those answers. For D and E. One more thing I want to point out about molar masses. We've been dealing with them for a long time. A molar mass is always 1 mole versus some number of grams. The coefficients never have anything to do with calculating molar masses. It's not 4 moles, it's 1 mole. Okay, but the 32 grams, it's not of an oxygen atom. It's not 16, which is what oxygen is on the periodic table. It's an oxygen molecule. So it's 2 times 16, so it's 32. So when you're calculating molar mass, you do take this number into account, O2, not just O. But you don't take this number into account. That's a number that applies to this specific problem. But for an oxygen molecule, 2 oxygen atoms stuck together, then 1 mole of them is going to be 32 grams. Okay, so be sure you understand that when you're calculating that. You use this number to calculate the 32. You don't use this number. You don't multiply 32 by 4. Do anything like that. Okay? Down here, same thing. CO2 has a molar mass. 1 mole is 12.01 plus 32 gives you 44.01. Okay, it's the mass of 1 mole of these. The 3 has nothing to do with the calculation here. This 3 has nothing to do with the molar mass here. Okay, you just take whatever the molecule or compound is and just calculate that for 1 mole. Okay, all right. So let's go on. All right, so we're on to problem number 2. That's 2 of the second problem. And again, this is an STP problem, even though I didn't print that on this. So it is, again, let's refresh our memory. It's 1 atmosphere of pressure and 0 degrees centigrade temperature. All right, so here's the reaction. And this is Li2CO3. Down below on a couple locations it just says LiCO3. It is Li2CO3. Okay, so there's the molar masses. I'm going to give those to you. You should know how to compute those on your own in case that's necessary. All right, so now we can go ahead and get started. So how many liters of H2O gas can be formed by 4.29 grams of LiOH? So LiOH is right here, and grams is down here. This is the grams row. and liters of H2O is up here, and here's the liters row up there. So H2O and in the liters row. So we need to get from here through this conversion. There's your first conversion to get to here. By the way, again, I did not draw, let's see, did not draw the dashed line, so let's go ahead and do that. It doesn't matter whether you put the moles up above the equation or down below, as long as it's in the dashed box here. All right. And I'm using, okay. All right, there it is. So there's the box. This is everything inside this dashed line is in moles. Okay. So we're going to convert from grams using the conversion to moles. Then we need to use this relationship, 2 LiOH equals 1. And let's go ahead and write the coefficients in front of that. It's a 1 there, that's a 1 there, and that's a 1 there. So 2 LiOH equals 1 H2O, that's in moles. Then once you get to this box right here, where you have moles of H2O, you use this conversion to come out and get liters, okay? So go ahead and try to set this up on your own. Pause the video, that's legal. Okay, so we're starting with 4.29. And it's 1, 2, 3 conversions. Okay, so everything is set up. Come down here. So our first conversion is to get from here into the equation using this conversion, molar mass for lithium hydroxide. Okay, which one on the bottom? You need whatever this one is has got to be on the bottom. So it's this one over here. It's grams of lithium hydroxide. Grams of lithium hydroxide cancels. Okay, so now you're sitting in this box right here. We need to go from here to here, so you just write that with an equal sign between it with the word moles. Okay, which one of these two goes there? It's got to be the same one as this one. So it's moles lithium hydroxide. Cancel and cancel. Okay, which one of these two goes on the bottom? It's got to be the same as the one that's on the top there. Moles of H2O. Moles of H2O, moles of H2O. Last man standing is grams of Whoops. All right, so now we're sitting in this box right here after this conversion here. Now we need to get out to liters of H2O. So our conversion is 1 mole H2O equals 22.4 liters. Which one goes on the bottom? It's the same one that you see here, so it's moles of H2O. And that cancels with moles. Last man standing is liters of H2O, which is in your final answer. So now you're going to simply multiply 4.29 times 1 times 1 times 22.4 divided by 23.95 divided by 2 divided by 1, and that's going to give us 2.006. We can go to 3 significant figures there and there, and to 4 there. So 3 is going to be our limit. So it's going to be 2.01. 006 rounds to 0.1 in the 3rd significant figure. And I'm not too worried about that. I just do it because it's there, but I'm not sweating that. In fact, I'm not even sweating the answer. I want to see this. Sweating means I'm not worrying about it if they're not familiar with that expression. Okay, there you go. I'm worried about that. All right, I want to see that. Okay, let's keep going. First, I'm going to go ahead and erase my question mark up here and my 4.29 number down there. Okay. All right, let's keep going. We can squeeze everything on here at the same time. How many liters of CO2? So here's CO2, and liters is up here, so that's the question mark. How many? How many liters of CO2 are required to completely react with 12.87 grams of LiOH? So LiOH is over here. Grams is down here. So that's where the 12.87 goes. Okay, so we need to get from this number up to this question mark. You need to come up through the molar mass of LiOH into numbers of moles, from numbers of moles of LiOH over to numbers of moles of CO2, and then from numbers of moles of CO2 through this conversion to get to the question mark. Okay, again, see if you can do this by yourself. That's the end goal here. Be sure you can do that. Okay, so let's go ahead. So we start off with 12.87. Okay, so that's what your equation should look like, starting with 12.07, ending with some number of liters of CO2. Okay, and your first conversion is going to be to come up to get into the dashed line box, into the equation, and that's you're going to use the molar mass of LiOH. Okay, which one goes down here? The one that goes down here is the same one that you see here, grams of LiOH. That's this one right here. Grams of LiOH cancels. Next one, we have to go from moles of LiOH. We're now at this box right here. We need to move over to this box. So it's the relationship, just an equal sign between those two. Okay, which one goes down here? It's It's the same one that you see up here, moles of LiOH, so this one does. Moles of LiOH cancels. So now we're in this box right here, and now we got to come out using this standard conversion at STP to get to liters of CO2. Moles of CO2, so moles of CO2 has to go on the bottom. Moles of CO2 cancels. So last man standing is liters of CO2, which is what you want. So we multiply everything on the top. 12.87 times 1 times 1 times 22.4 divided by everything on the bottom, divided by 12.87, divided by 2, divided by 1, and that gives us 11.2. And we're limited to 3 significant figures, so that's going to be our answer right there. Alright, let's do C together, and then I'll give you the answers for D and E, and you can do those on your own. So use the graphic organizer the same way I am, just go back, erase each time. Alright, C. How many grams of Li, and it should be Li2CO3, so we're going to come over here, and that's going to be Li2CO3, this is the grams row, and it's how many, so that's the question mark, are formed from 14.01 grams of LiOH. So this one is grams to grams. This is like the ones we did in lesson 12. 14.01. Right there, you don't have to write grams because it's in the grams row. So there we go. Okay. So the conversion is from 14.01 up through the molar mass of LiOH. From 2 moles of LiOH equals 1 mole of Li2CO3. And that's your second conversion. And then your third conversion is using the molar mass of Li2CO3. That's lithium carbonate, and that gets you to there. Okay? All right, so let's set it up. That again. There we go. Okay, so there you go. It's 3 conversions. First one is right here. It's the molar mass of lithium hydroxide. Go ahead and write the rest of them. 2 moles of lithium hydroxide for every 1 mole of lithium carbonate. And the final one is the molar mass of lithium carbonate. Okay, and let me get on screen there. So there's the 2 moles LiOH, 1 mole Li2CO3. Okay, so that's this one to this one, and then to come out to the question mark, you need the molar mass, and that's this one down here. Okay, so which one of these two is it going to be? It's got to be grams of LiOH. Cancel and cancel, and the other one goes on top. Okay, so for these two, which one goes on the bottom? Has to be the same one as this, so it's moles of LiOH. Moles of lithium hydroxide cancels. Okay, finally the last one is the molar mass for lithium carbonate. Which one is it? Which one goes on bottom? It has to be moles of Li2CO3. And the other one goes on top. Okay, cancel, cancel. Last man standing is grams of lithium carbonate. So now we go ahead and we multiply 14.01 times 1 times 1 times 73.89 divided by 23.9, should be 0.95. Divided by 2 divided by 1, and that's going to give us 21.6, and we can go to actually 4 significant figures in everything here, so it's 21.61. Okay, and there's your answer. Okay, now I'm going to give you the answers to D and E, answers only, not the solutions. Okay, so we're back. So here are the answers to D and E right there. So go ahead and write those out and just check and see how you did against those answers. Okay, for number 3, it's just a simple proving to yourself that 1 mole of any substance at standard temperature pressure equals 22.4 liters. So we're going to say we don't know how many liters it is. So we're going to put volume equals some unknown number. We know what it is, but we're going to assume we don't. We're going to use the formula PV equals nRT, which if we solve that, we're trying to find volume, so we divide both sides by P. Cancels, and you end up with V equals, okay, so there's volume. Pressure is standard pressure, 1 atmosphere at standard temperature pressure, and that's the key to the problem. And we're asking about 1 mole, so that's N. In this equation, that's N. Temperature is 0 degrees centigrade. You add 273 to that and you get 273 Kelvin. And the gas constant is liter atmospheres over moles Kelvin. So now you just plug each of these knowns into this equation right here. And I'm going to let you do that and verify that you come out with 22.4 liters. And again, it doesn't matter what the substance is. There nowhere in here does it identify carbon dioxide or oxygen or any kind of particular substance. Okay, so I want you to take these four numbers, plug them into this equation, cancel the units, be sure the units cancel properly, and then come up with your final answer. It should be 22.4. Okay, so you do the rest of that problem. And then I'm going to do, tell you what, I think I did this one in class. I'll do this one. All right, so you got a lot of squares in here. So if you want, you can rewrite it like this. Grams, atmospheres, and it's moles squared. So you can write that as moles times moles. Again, all these spaces in between are times signs or multiplications. Times Kelvin. Atmospheres, Kelvin squared is Kelvin times Kelvin, and moles. So numerator top, numerator bottom. Down here is liters, and it's atmospheres to atmospheres cubed. So it's atmospheres times atmospheres times atmospheres. Again, you don't have to do this if you feel comfortable canceling these exponents. You're good with that. And then it's grams times grams. It's grams squared. Finally, you got liters times liters times liters. Liters to the third. Kelvin times Kelvin times Kelvin times Kelvin. And then you got atmospheres squared. Atmospheres, atmospheres. Okay, so let's start at the top. So numerator top will cancel with numerator bottom. We don't have any grams on the numerator bottom. Or with denominator top, because they both have the word top in common. So this gram will cancel with one of these. So we're going to say it cancels that, so those two cancel. Atmospheres. Numerator top will cancel with numerator bottom. There's an atmosphere there, so we can cancel that. Moles. Numerator top can cancel with numerator bottom, so moles cancels with moles. We have moles again. We don't have any moles in numerator bottom anymore, but how about denominator top? We don't have any there either, so this is going to stay. Kelvin. Numerator top cancels with numerator bottom. And we're done with the numerator top. Now we can go to the numerator bottom. The only thing we have left down there is this k right here, and it can cancel with denominator bottom. So it's going to cancel with one of these k's. So now we have nothing on the numerator bottom. Okay, liters. We have liters in denominator top and denominator bottom, so they're going to cancel. Okay. Atmospheres, we have atmospheres, denominator top, denominator bottom, they cancel. And another one, atmosphere cancels. Okay, and then grams, no more grams. So we don't have anything else we can cancel. Just verify that for yourself. So this liters, liters, Kelvin, 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 and grams here. So let's kind of write this out, because this can be a little confusing. This last part for some students is a little bit confusing. So what do I have up here? I only have moles here, and I have nothing in the numerator bottom. So I'm going to write it like this. Moles, nothing really means over 1. You made everything cancel, so it's over 1. And then that's going to be over, the only thing you have in denominator top is grams. And in denominator bottom, you have liters, liters, Kelvin, Kelvin, Kelvin. The way you can write that is liters squared, Kelvin to the third. Okay. All right, so remember what you do with fractions. You flip the bottom and multiply. So that's going to equal, you don't do anything to the top, mole over 1 times, flip the bottom, liter squared. So if it's on the denominator bottom, it flips all the way up to the numerator top. Kelvin to the third, and then you flipped this down to the bottom, grams. Okay, so your final answer is going to be moles, liters squared, Kelvin to the third, over grams. So it's more than it. Okay, and that would be your final units of measure after all that cancellation. So be sure you know how to do that, right? Don't just copy it. Be sure you got what the steps were. And then this one I believe we did in class, but whether we did or not, it's much simpler than this one, so go ahead and do this one on your own, okay? All right, that takes care of this. It's a fairly long answers video, but go ahead. This is due on Wednesday, April the 21st, I'm going to say it is, and go ahead and turn that in by then, okay? All right, have a good rest of your weekend.